need to switch this. Yes. Hey, everyone. How are y'all doing tonight? My hair is poofy. Oh well. Hope y'all are having a good night. Sorry I started a little late today, but it'll be all good. So I am planning on doing some game development tonight. Specifically, I'm going to try to implement Dijkstra's algorithm for planning a path from our current location to our destination location, and yeah, we'll go from there and see what that looks like. Yeah, so I'll go ahead and switch over. I found a few websites. Let's look at this. I zoom in. This huge thing, but so this one's just shortest path algorithm. Dijkstra's is actually, it's generally used for graph planning, or like finding a shortest distance between one point in the graph to another point in the graph. But you can essentially generalize that to also do a path planning in a grid, because a grid is essentially a graph with, you know, every cell connected to every adjacent cell in the XY, you know, routes. And if you support diagonal, that's another connection where the unit cost of every single, basically, connection is just once, or one. The distance value is just one. And the node values are also just basically zero. And so it's just a generalized form of this particular, you know, directed graph search. Yeah, so this guy wrote some code. The pseudocode for this pseudocode's always relatively hard to understand because they generalize it in such a weird way. So there's this explanation up top, but then we have a pseudocode down below. So it's always kind of hard to follow because they have just like non-typed anythings, and it's just almost like English, but you have to try to discern what the hell they're actually saying. So this one takes a graph, the graph being, like in this example on the right hand side, all the nodes. And then for each vertex V, which would be a point in this particular graph, in our case it would actually be the like cell location. So 0, 0, 1, 0, 2, 0, 3, 0. Those are vertexes, or vertices. And then the distance would just be 1 from each one. So it doesn't really, you don't really have to do too much here. So all this does is this just initializes it. So you create a vertex set of Q, which is just out all the vertex or all the vertices in the graph, and this just sets their default state to the distance being infinity, the previous value being undefined, and then we add it to the Q, the vertex set, and then we define the starting point's source distance to be 0 because you're there, so obviously it doesn't cost you anything to go from where you are to where you are. And then basically iterate over this whole thing. Hey April, thanks for the like, appreciate it. Yeah, so then we basically go through the entire vertex set. So we visit every single vertices in this graph, and you'll notice, like in this graph over here, the blue line is what it's checking every time, and every one of those times it's just identifying a minimum path, to the shortest path. The red lines are the shortest paths that it's finding from one node to another node. Yeah, so basically we go through each node, and then we find the vertex in Q with the minimum distance U. See, and it's like, where do U come from? What the F? Okay, I think it's just saying. So this would be the dist, the source location basically. So you remove that vertex from. Yeah. So in this case, it's just saying in this set of vertices, so like all of these, this vertex set has all of them, but we initialize the distance for every single one of the vertices to be infinity, except for the very first starting one. So this just says, give us the vertex in Q that has the minimum distance. So you'll start with this node essentially, which will have a cost or a distance of 0. And so it removes U from Q, so you don't revisit it. And that's where it's basically saying like you only visit each node once. And then for each neighbor V of U, so that's you'll see in this algorithm, it's like it's looking at all the neighbors of you see the blue lines, that's it looking at the neighbors of a particular node. And it's obviously only the V's that are still in the set. So if you previously removed a vertex from that set, then you wouldn't revisit it. And then you just take the distance of your current one, which we'd be working with 0, and add the length from U to V. And that's the alternate distance. And if that alternate distance is less than the distance of V itself, which it will be because that distance will be infinity for all nodes except for the main one. And so it just sets that distance and sets the previous distance. I think that's previous. That's just the previous node that was visited, I think. Yeah, so that's how you can trace back from one location to the other. So all this, this is only part of the solution to the problem we were trying to solve. So that basically just goes through an entire graph and gives cost to every single cell to go from one place to another. It's pretty boring for us because it's essentially, the distance from, it's the Manhattan distance, you could say, from one point to another point. So it's not really valuable for us. But this is just the general Dijkstra's algorithm. So we can, that's why I actually followed the second link, which is Dijkstra's shortest path algorithm, which gives a little bit more, guidance into actually taking action, saying you want to get from one point to another point. And I was looking at the C# stuff. It's actually very hard to read in this case, so you can kind of see that. Single source shortest path algorithm for a graph represented using adjacent matrix representation. Okay. So this is basically holding the distance from source to I, which is fine. This is setting the infinite and setting it as not seen, I guess. And then this is setting the distance of the initial to be 0. So that follows that same pseudocode. So what it's doing there is essentially this. And then it just finds the shortest path for all vertices. To construct a distance array. Yeah, even this doesn't really. Okay. Boom, bam, bam. Just take like a. Okay. Yes. These are just made to handle much more complicated situations, because if you look at this, this is their adjacency matrix. So you have that like 4 and 8. That's like the cost of that node, which is, we don't really have that. It's really just it's much more simplified than that. Okay, so I think, what if they, what if somebody's implemented this for Unity? Wait, that was whack. Why did it pick that path? Look at this path it picks. What? Oh man. Yeah. I wonder if they keep it separate, like, yeah, so they have a list of nodes? That's interesting. Oh, they get a node component, which is like a, okay, that was something I was thinking about doing. It's always fun to make sure that, to see how other people do things. So I imagine this node pretty much is like a very basic like shell of like the pieces of information they need to know. Yeah. So it's basically just this wait, which is not really useful. The parent node, I guess the parent node's for following the path in the end. But this is the more useful piece of information, which is the list of neighbor nodes and whether it's walkable or not. The tricky part is, so like if we tried to implement this using that, like this kind of node structure, the idea is this script would actually be on every single, you know, cell, which is not entirely true in our case. So like if you look at his code or his example, like he just generated all these nodes. So every single one of these nodes has that node script on it. So he kind of gets away with that. But with ours, with the tile map, especially like an example being obstacle, the obstacle node doesn't actually have a node. It's only partially filled. So we can't depend on that to have a node script on every single tile map cell in there. So I think we need to take the tile map and generate a codified version of that tile map in memory that has something similar to what he had, the node J or the node CS file, that has like, you know, the list of adjacent nodes and the list of like your parent and stuff like that. I don't think we need wait because we don't really have wait. Actually, I'm curious, did he actually set anything different for a wait? Because I don't think so. Like generate grid, for example, instantiates the game object, and okay, so there's a node prefab. Yeah, has the neighbor nodes. Not too crazy. Okay, nothing there that seems to show that he uses weight. Like, I want to know what he uses this junk for. So set weight. Is this called set weight? Bum bum bum. He does. Okay. Okay. This makes sense, I think. Yeah, that's interesting. Cool. Yeah, so we're going to create something very similar to his node. What's a serialized field? I've seen that before. In the world of C#. Oh, what does that mean? Can you serialize your scripts? It only serializes public fields. If you want to unite or serialize your private. Huh. What's it used for? Script serialization. Huh. Just affects how your game performs, how it serializes, unserializes, and hot reload and stuff. I don't know. It's a significant amount of stuff. Okay. All right. So what we're gonna do. All right. Let's go open up our script. Wrong one. We'll create a node CS. Might just yoink his node though, because it's like super. It's just like a. Oh, it's a mono behavior? Okay. Just kidding. I'm gonna yoink this, but minus the mono behavior. Because all this is a. I care more about the fact that it is a class, basically. And I need to add it over here, I think. I think I have to do something like, so if I don't want it to be a mono behavior, then I need to make it namespace. because yeah. So this is neighbor with a UR. Is that like a? Is that an English thing? Like a. It's the same. They sound the same. The only difference is the way they're spelled. Yeah, British English. Okay, good to know. Apparently, that dude's British, or more familiar with British English, maybe. We'll call this. Why does he do this? Okay. So I'm going to use this essentially to generate my 2D grid based on my 2D grid in memory versus my grid tile map grid, I guess. So if we look at their shortest path, I imagine they just have a list. Yeah, so they have a list of nodes, but in all honesty, it's more of a it's really more of a list of like those game objects. I imagine they pull the node object off the node script. Bow, bow. Yep. And then they. Oh, that's jacked. So they pull the nodes object and then they call this and they don't pass it through. But I almost guarantee they use those nodes. Yeah. Yep. Okay. That's what I was looking for. They basically look for the list of they don't actually use the game object itself. They pull the node script off of it. So I'm just like eliminating a level of complexity. Not really a level of complexity, level of abstraction. So they have this list of nodes. I really am just gonna hold on to a let's do path planner. So like this thing is gonna have like a private planner. The only tricky part. Yeah, the only tricky part is the fact that I need to be able to do. So let's just say I generate the map or the grid for the base level, which is fine. And that part's easy. To give more, so this green area, I can just go through this grid and essentially generate all these tiles into nodes here. The tricky part is if I go through all the tiles of the obstacle side of things, then I want to be able to go and look up in the node map here. So like based on location, so that I can set them as obstacles. And in this current manner, that's not easy. I wonder how he... The generate grid is probably pretty... So he instantiates a node. He adds it to the grid. Oh, the tabbing's all effed up right there. That's why I was so confused what he was doing there. Got it. Okay, so that's how he does it. He generates all of them, but then oh, that's brittle as hell. This is brittle as shit. I would not recommend doing this. He's using like the size of the grid and stuff to essentially modulo over columns, and then which gives you what the remainder. If you modulo, like if you modulo 4 by like 3, you'll get 1, because if you divide 4 by 3, you get 1 remainder. So he's doing some kind of sketchy shit here to make that happen, because he doesn't have a 2D grid up here. It'd be so much easier just to do a 2D grid, and I think that's what I'm gonna do to avoid this nonsense. I am curious, like 2D array C#. I think there's a fancy way you can do this. Multi-dimensional arrays, like a comma in between? Yeah, like I want to, like what the... Wait, what? Arrays can have more than one dimension. For example, the following declaration creates a 2-dimensional array of 4 rows and 2 columns. Okay, that makes sense. 3-dimensional array. Back up, yeah. Okay, so that's fine. And so in my opinion, we should do this. So then we can just do the straight lookup based on XY position and call it a day. The only tricky part is the fact that the lookups in the grids, for example, will likely be potentially negative. So like if we... Okay, so if we run this real quick just to show you what... Let's see what we're working with here. So the grids that we have, there's 2 tile maps. The first tile map is basically our ground one. It's our large grid, and it's 74 by 46. So, and it starts at 0, 0. So it goes from the origins actually. Wait, is it? It says the origins at -37, -23. What? What? That makes no sense. Let's do this. So the cell bounds. The center is at 0, 0. The max is 37, 23, and the min is -37, -23. So that makes sense. Yeah. Okay. So I guess my point is, like, if we're looking at this, like at the very center of the screen will be 0, 0, essentially where our dude is. That'll be 0, 0. But if I click somewhere down on the bottom left, that'll be negative in the X and negative in the Y. And you can't do a lookup in an array with a negative value. So essentially what we have to do is compensate for that by making sure everything starts from the bottom left and we index it appropriately. So luckily we can use the size. So the size is 74 by 46, which is the actual full dimension of the array. And then trying to think what kind of fancy math we could do. Because what would happen is that like a negative 37, negative 23 would actually be 0, 0 in the array. So do we just add the, I think we just add the maxes, right? I think that's right. All right, we can give it a whirl and see what happens. We did some testing last time to make sure, like when you clicked, that that the position is correct. Position, the position. So like if we click where our dude is, you'll see press primary button at 1023 596. That's a pixel location, and that translates to 0.6.5 negative 9.5. That's in world coordinates, and in cell coordinates, that's 0, 0, 0. And then if we do this one, it's 0, negative 1, 0. So essentially, we can do something similar to that and make sure what I am saying is actually true. So, yeah. So nodes would be like new, and we would do I'm gonna actually separate these out. So I still have no idea why they make me fully qualify this tile map thing. I guess because tile map exists in the Unity editor as well, which I guess by default is imported. I don't know. Actually, did I already? And I can come up with better ways to actually identify this, but for right now, we know that the ground grid is equal to 0, and the obstacle grid is equal to grids 1. All right, so then is it cell size? Cell is, it's cell bounds, and there's a size. I think it's cool. I think it's smart enough to know that, like, because it's, nope. It is not smart enough. Yeah. So you just have to, okay. So that'll initialize the nodes, or the node array at least. Okay. Okay, so we get the mouse pointer in the world, and then we can convert that to sort of vector 3 int, something like that. Yeah. So vector 3 int is mouse point cell. All right, so that's the cell location. And we're gonna add, I think, the min and max. Let's see. No, it's just the max. Max X and max Y. Private. We'll do a vector 3 int. Node location offset. So that would be node location offset equals new. We do. Let's see. So ground grid cell bounds. It should be max X. Oh, max. Oh, that's easy. So just that. Feels wrong, but I think it's right. So then we can just do the mouse point cell and add it using shoot, what I called it, node offset location. So that should give us, so if that point, so 0, 0 should be, let me write this out real quick. So really it's negative 37, you know, and then 0, positive 37. And then I think it's 24, you know, and then negative 24, something like that. But that's like real cell, like grid lookup in the tile maps. But in this new world, technically this would be 0, 0. So this would actually be 37. Actually, a better way to put this. 0, 37, 74. And then this would be something like this, right? So the middle should be 3712. 37, no. That's correct. The middle should be 3724. Right? I'm not losing my shit on this. I think this is right. Let's see if my math works out. $37.23. Hold up. Hold up. Wait a minute. Just one momento here. Somebody's effing. Double check my numbers here. So the ground grid 23. All right, so I messed up. By mess up I mean my thing here is wrong. It's actually 23, 23, and this is 46. Okay. All right. So we're perfectly fine. So this 3723, fine. This should be 0, 0. Or am I not? Wait a second, what? Oh shit. It's the whole grid. No. Because I'm only actually seeing a small portion of them. Oh, that's mind-blowing. Not too surprising though. Just makes it harder to verify what I'm trying to verify, which is irritating. Alright, so let's do this. I'm actually going to delete a load of this stuff. So ground level base ground. Let's just do like grid level 0. And we are going to I feel like there's a way to do this better. Is it this way? Oh, Jesus. My lack of understanding of how to do tile map stuff is hurting me right now. Just because it won't let me. Oh, God. Can I just, like. No. Do that. Delete doesn't work. It's not even my Ah, beautiful. Didn't do that on purpose. God, this thing's whack. Okay. Alright, so theoretically, now my grid should be much smaller. So let me just double check. So attach again. Now it's still massive. What the F? Maybe it's because at one point it was that large. Yeah. Alright, so here, let's start this. Nope. Okay. Trying to figure out how I can cause this thing to not render the entire world. Because right now, even though I cut the size down, it's still 74 by 20, wait no, 74 by 46, which is kind of frustrating. Yeah, it's just, it's frustrating, but it doesn't really matter. So I'll just deal with that. With that, it should be fine. I'm just gonna trust that that is actually correct, that this node offset we can use to compensate correctly. Okay. Um. I don't need that. Oh, yeah. Now, what I'm gonna do is essentially go through. If there's a way for me to get like tiles, active tiles. Give me them tiles. Refresh tiles. Refresh all tiles. Swap tile. So the only way that it looks like I can get all the tiles is if I where'd I find it? I found it down here somewhere. Give it a block. Choose an array of tiles with the given bounds. I mean, this is the seems excessive way of doing this, right? So like int I wonder if I can do I think that's so I'm kind of spoiled by Golang, because Golang, when you initialize a slice, for example, which is backed by an array, the length is set at that time when you initialize it because it allocates the memory. I don't know if that's true for this case. A little bit of C# inexperience here. Wait, what? Oh, Jesus. So 3,400. That expands out. Is it 74 multiplied by 46? Yeah. Sweet Jesus. Oh no. Why would a... Ah, okay. There is a way. So that's what I want, actually. So if you get the length of this, let's try this again. Yeah. No. think I got it in time. Oh, didn't even start it. Alrighty then. Alright, so that works. And it does actually use the correct value even though it hasn't been filled yet. Alright, so okay, so then we can essentially go through the weird part is you actually have to negate the compensation. This location offset. That's weird. So many weird things. Gosh, can I just like... Nope. I can't just import that. Using these. Oh, thank God. I was very, very worried that there was going to be another node class in, you know, C# somewhere. So node, a new node. So I think, so yeah, there's a few things I actually... So int... Just keep track of these. Don't know if... Start? Oh, because... Huh? What the hell is this thing talking about? Okay. So int... Can't do that either. Fortunate. Oh. I wonder why it was okay with that. Or how that other dude thing actually worked, but whatever. Oh, it's okay with that. Interesting. It's okay with us setting the parent node to null? Is that... That is nullable, I guess. Now it's just insane. Like, what the hell are you talking about? I literally assign it in the same line. Let's see. No node. Does it need to be a float? I guess we can leave it at that, whatever. A float max. So the XY location is the XY location in the that's the XY location in our local nodes lookup, which is arguably not very useful. What we actually care about is the XY location in the grid. Do we though? Do we though? I mean, we can always compensate for it. So vector 3 int the grid location is actually new vector 3 int. Oh, they don't have an overload where you don't take a z? Oh, that's lame. X minus, actually let's just do xy 0 then grid location. Ooh, can you do this? This would be fantastic. Solid. So then in this case you would do ground grid dot get tile. Actually, really care about the obstacle. It's really this one. So we just want to make sure that we track when it's an obstacle. Alright, we're gonna give this a try. Compensated cell location. Yeah. Or how long it takes to run that. It's like 3,400 grid locations, right? Should be super fucking fast. Alright, so initialized. Actually, it does all the Y's first. Okay. Okay, so that's fine. Actually, here's what I'm really curious about. So if this is true, there is a tile for the obstacle grid. Mainly just that. So let's stop this and save this, attach again. Let's run again. So we should get 4 hits, right? Right? We got none. What the F? Okay, so what is this? 42, 25, 1. Oh, it's wait, 1? Are you fucking kidding? Oh, they're all 1. Oh, that's the problem. I think I set it to friggin' 0. Oh, Jesus, that's just an annoyance right there. Alright, so now I should get 5. Yeah. So that's compensated grid location. So this is 0, 1, 2, 3, 4, 5. And then 1, 2, 5, 2. Solid. And 6, 1, 2, 3, and then 7, 2. So that's in the 0, 0 plane. Okay, that seems right. We at least have our obstacles configured correctly in the grid. Can take that away now. Sweet. I think I do need to be consistent. I think everything should work in compensated locations, in grid locations essentially. And the only thing that should ever think about things being in a world where 0, 0 is in the bottom left, and you know, in this case, 74, 46 is in the top right hand corner, is the path planner itself, maybe? So I would argue that this shouldn't take this. So it should have actually a vector 3 int like grid location. I don't think this is used for anything, but so this because the XY position we actually don't use for anything besides doing lookups here. All right, that seems to be making sense. Okay, so the other thing that this needs to do, so it needs to always have the current player's location. So it currently looks up the grid. The other thing that we would want to do is find object with tag? Was it? Son of a... I don't remember what it's called. Shoot. Gosh darn it. Unity find by tag. Oh, you gotta fully qualify it? Lame. So game object dot get find object game objects with tag. You think player would be like an acceptable enumeration value that they have, but I guess not. Yeah. So then you have private game object that is the player. Hello? Okay. Okay, and then what we can do is like update player position. And then we can just take, you know, player dot local position, basically do world to cell like this. Dang it. So I'm going to create a method. I'm going to create a method in here that compensates. So private void, actually not void, vector3 int get local array. Sorry, it's a local grid. So get local grid position from world grid. Local grid from world grid. And so what that should take is vector3 int Why is it mad about this? Oh, because it doesn't return anything? Yeah. All right, so world grid, we need to subtract. So it would be return world grid minus the node offset. Right? Not quite. So close, and yet so far. And then this would be the opposite. Okay, so in that case, so this one gets the, this is the world grid location. Which I think is fine. It's no big deal. So like private vector int current player position. We only really, I guess we don't really need to do that until they click. So it's like once they do this, it might be good to then we can get the mouse position. Jesus. Took me 7 tries to spell position. Okay. So then we have basically, that's the world position. This is the, so actually this would be, you know, get local grid from world grid. Okay, so I think we have something relatively useful so far. This determines, is basically, this is the world cell location. To local cell coordinate location. Because I imagine if we kind of, what's this thing? Because it's not red anymore, I guess. If we think about how the planner is going to work. So what we can do, we can just create a separate, over here. Stop this. Go to scripts, create. I just wanted the name that I didn't have to like try to fat finger that name out. So namespace. These don't actually matter. So there's basically, I think, three that we can start with. Just variations of the different ones here. So path planner will basically initialize the planners. Some of the planners may actually need something. Dijkstra doesn't, but some of the other ones, if they use a different heuristic or something, they may need additional initialization. So I'm just gonna create this for now, in case we need those. But we'll start with Dijkstra's for now, and go from there. But yeah, I can create like a interface for this at some point, but essentially Dijkstra should have what should it do? Let's okay, I stopped that already. Oh, this is still running though. Interesting. So it's really just coming up with the path plan. Execution of that's a different problem. And we can expand upon that later, but so there basically should be nodes, right? That's the graph that we're searching on. We need a start and end node. They call it like source and destination or some shit like that. But I think they do something like that, right? It's like ideally this is like a interface, right? Wait, what? Oh. Let's see. How do they do interfaces in the C# world? Yeah, that's what I thought. Okay. And I think C#'s super gung-ho about the I. So interface like path planner, right? And then there would be like this. I don't think you have to put public, right? Or do you? Do you? Well, I am. So. So it like, is it mad about that if I don't put it? I think you can get away with not putting these as well. Right? Or is it picky about that? Oh shoot. It is picky about that. That's weird. But okay. So we can do those later. Okay. So then if we come back to the planner over here, theoretically, here. So we have to be consistent with the locations that we give. They should the start and end locations should be either the world locations or the local locations. And I think it should always be world locations. And then the planner will have to do the local translation. That seems... Or should it? It actually doesn't care. Oh, interesting. It doesn't matter. Oh, thanks. Thanks for the light, Grandma. Hope you're having a good night. Because I'm passing in nodes, it's irrelevant. All that I'm talking about is actually relevant. So here. So what I really want is, you know, node player location. That seems fine. No dia. Alright, and then the second one would be basically get a selected destination location node. Okay, generate that one and generate that one. This would basically be get the current, you know, player location is pretty straightforward. You get the player's current. So that's world. Player world position. And then local position is just equals get local position. Player world position. So this should do the mapping. Oh my goodness. Well, there we go. Then we should be able to return feels very fragile. Alright, so this is just going to do all the mousy goodness. So get the mouse position here. So doing there. Then this. Boop. Alright, so then we just do player location, destination location. Okay. Hope that makes sense. Basically, I'm not sure we should actually do this live in the update loop because this could take a little while. Not a long while, but you know, long enough that you don't want it to be run during a single frame update. So we should probably execute this in a coroutine or something, but good enough right now while we test some things. So let's just do this. Index was outside of the bounds of the array. That's always fun. Okay. All right. This is interesting. Local grid from world grid. Oh, that's add, right? And I subtract. Yeah, I did these backwards. Wah. So if you're going from world grid to local, you actually have to add to it to be able to pull it down into the left-hand corner, I think. Nope. From node to node. That's useless. So I wonder if there's a... like a way to generate... Nope. Wait, what? Sure that there's some... That's not what I wanted. Alright, well... Oh, maybe I have to do it up here. If I do like a... Huh. This is really I really want. So it should just say like from 0 to 0, yeah. If I do this, be 0, 0 to 5, 2. Okay, so at least knows now the places it's trying to plan from and to. So that's correct. Alright. Alright, I'm feeling good about this. I think this might be where I stop for tonight, and we can work on implementing the algorithm next time. Because this is, I would be very surprised if I could knock this out in the next hour. Yeah. Let's see, is anybody playing? I'm gonna play a little bit, literally like a second of Apex, and then I'll have a hop off for the night. But yeah, so Monday, ideally, it is Memorial Day, so we'll see if I see if anything comes up. But idea is Monday I'll actually implement a planner that will show us essentially what. I probably won't execute it, but we should ideally at least be able to plan and say like this would be the path that we're going to take, and come up with some way for it to be drawn on the screen. I'll have to figure out how we do that, but yeah. I think the other thing I still have to do is set up this these neighbors. So that's something to be visited still. So I'll do that next time as well. Cool. Alrighty then. Let's play a quick game of Apex to get my treasure pack. Hopefully, that's the hope. I'll head off for the night. I also got a pen tablet. I think that's what it's called. Like a little drawing thing. Let me try. I'm pretty terrible at drawing, but maybe for low resolution things, I can figure out how to be better at it. So I bought one of those to mess around with, see if I can like do some of my own art on certain things. So, we'll, I don't think I'll stream any of that, but we'll see. Maybe it'll be interesting to see the random stuff I come up with. I do not want to play this guy if I accidentally don't pay attention.
If you can't keep up, you're straight out of luck.
Fingers all jacked up too.
I'll never be.
I got an ingrown fingernail or some garbage. Makes playing this game extremely difficult, by the way.
Introducing your champion.
Because it's my middle finger, which is the key that you use to move forward and backwards.
Don't rush to your end.
Not ideal. Even typing's kind of shitty. Where's he going? Hold up, this dude's Pred? Or was Pred? Maybe not Pred so much anymore. He's going straight hot. Oh, we're gonna get lit the hell up. I hit him with the charge rifle, of course, but then missed him with, it was like a halfway loaded G7. Like, what the hell? Picked it up and I'm like, all right, now let's do this. Didn't even know that was a thing. He's like, that dude was Predator. Like, how? Like, why would he drop there? I don't know. Just seems bad.
Enough flirting. Save it for when we win. Party. Let's rock.
Need to get back into Final Fantasy VII Remake. I gotta finish that game before somebody spoils it all for me. On accident.
Your champion.
There we go. That's our champion from last match. Dude has 0 kills.
Hey, I'm the jump master. Ready up.
Maybe he plays a different character, but still pretty where you wanna go, bro?
Let's land here.
So we're going.
Jets, we're dropping hot.
Oh shit.
Arc star out. Fire. Spotted. Jump drive out. Incoming frag. Body shield here. Level 1. You need one if you don't have it.
I'm blaming my man.
Round 1.
Get the hell out of here too.
Countdown.
Hold on, I need to heal.
some crates, bro.
New kill leader appointed. New kill leader? Interesting. Jump driving position.
That was kind of a waste, bro.
Target over there. Putting lead down range.
Fire! Damn it, that hurt. I'm down. Enemy here. I have eyes on the enemy.
God, that's such trash.
This way, let's go.
Double timing it.
What? I hate the EVA 8. What the hell? EVA 8 was like a random lottery bin. What am I gonna roll this time? Oh, 11-7. Oh, 18-13. What the f...
Time to dig up some gold.
Spent gunpowder. Smells like victory.
Introducing your champion.
Still in the treasure pack.
I'd watch out for my squad if I were you.
Stay on me. I'm the jump master.
I'm going to Bend City over there, man. It's been
Let's touch down here.
the rig. It's like 50 bins over there. I'm bound to get a treasure pack out of that so I can get out of this. Absolutely abysmal performance on that last game, man.
Hold on
Jesus.
tight. It's time to drop, shock, and rock.
First blood.
Got him.
First blood on
First crate.
when you get to excel. Open supply bin here.
Ring spar, ladies. Oscar Mike. Longbow here. Get the skull piercer hop up and watch him drop. Havoc rifle here.
Attention.
New kill leader?
Nice. Champions out. Meat
Really?
Wagon's having one hell of a day. Hustle. Got me.
Down. Reloading.
Enemy spotted.
Reloading.
Hostile. Danger close.
Shooting at me. It's your lucky day.
Nice.
I got you.
Pause. my back.
That dude absolutely wrecked me.
Massive here.
I don't want that garbage. And by garbage, I mean one of the best games guns right now. But, ooh, wait a second. Wait. Oh, dude.
Ring's closing in 1. Healing. Watch my back. New kill leader. Watch your six.
Don't drive out.
Healing. Watch my back.
he's
5 seconds until
he's
the
for
ring
these
closes.
freaking things.
Gotta have an diamond bomb. So let's go. Hop up here. G7 scout here. I need a hop up. Skull piercer.
Golden.
Welcome to the shop. I've got just starting tower here. You never say no to me.
Dang it.
It's on. Ring's moving.
Ah, Jesus. Finger hurts every time I try to. Do anything weird. Oh, there's an R9.
Nice choice. You got good taste.
Attention. Delivering care package.
Ooh, care package on the way.
Ooh,
Like the
care
sound of
package.
that.
Actually, I'm not surprised I lost that battle with that caustic, because I think he had a 301 and I had a Spitfire.
Activating jump drive.
Like just the rate of fire and stuff on that. I'm not surprised at that outcome.
Shield battery here.
Thanks, beautiful. Looks like that's been looted.
Let's check out this area. Solid cancel that.
So many guns that I should take besides this garbage. Spitty. But I need them. Need the damage.
Let's do some shopping.
Wait, what?
Ultimate accelerant here. Get the job done faster.
You are coming home with me tonight.
Very, this lady insinuates a lot.
Let's go here.
You just calm yourself. Ow. Finger hurts. I gotta use the side of it or something.
Kill leader eliminated.
Someone's been here. Keep
Solid
an eye out.
copy.
Hop up here.
Select fire.
I need a hop up. Skull. I need a sniper stock.
Which way you wanting to go, my man? We are not being decisive right now.
Barrel stabilizer here. Level 3.
He said, look at this thing I'm about to pick up. Got him.
Sniper stock here. Level 1. Helps maintain that sight picture.
Aren't you sweet? Thank you.
Round 2. Beginning ring countdown.
Body shield here.
Level 3.
Wait, what? Why wouldn't you pick that up? I need a bigger backpack.
Extended light magazine here. Level 2.
Not sure about this dude.
Extended light mag here. Level 2.
Why would I need that when I just ping?
Standard stock here. Level 2.
Shield battery here. New kill leader. Call him if you spot him. One minute. Rings nearby. Tango spotted.
45 seconds until the ring closes. We've got time, but not much.
Got an extended sniper mag here. Level 3. Ring aim far. Half of 1.
Let's go here.
Roger.
Guess he hasn't done a sniper mag. Level 3.
Hold on, I need to heal.
He just now didn't realize that he had low health.
10 seconds. Ring's just ahead.
Warning.
Let's
Purple
reposition
shield down
here.
there.
Progress.
Forget that. Open supply bin over there.
We're all outside the ring, and a wall of death is coming our way.
Sniper stock here. Level 3. Helps maintain that sight picture.
Care package being delivered.
Target over there.
Care package on the way. I like the sound of that.
Oh god, this is a terrible position. Absolute worst. Team zipped over there, and there's one up top of here, I think.
Beginning ring countdown.
More towards center. They were sniping.
Jump drive set. They're shooting at me. Firing. Healing. Grenade. That hurt. I'm down.
Take it back behind here.
Cover me over here. Give my shields a recharge. Hold tight. I got your back.
Third parties, baby. All day.
I owe you one, beautiful. Healing.
Contact.
Bamboozled Mirage over there. I'm getting in here.
Everything here is gone for good. Activating jump drive.
Rings next door. 45.
I see someone over there.
Roger. Downrange. Reload. That would give my shields a recharge.
We've got 10 seconds. I need watch out, enemy there. Time's up and we're not in the ring. Move now.
Delivering care
We have a
package.
new kill leader. I can't wait to meet them. Ooh, I feel good about this care package. Shall we? Using jump drive.
Let's reposition here.
Shooting.
Reloading.
Reloading.
Attention. The kill leader has been eliminated.
We took out the kill leader. Rocked him and dropped him.
Oh god. Should I get rid of this Spitfire? Probably should. But I'm sticking. Sticking with it.
Quick, here. Enemy there.
There's another squad! Spotted. Confirmed hit on target. Give my shields a recharge. Double timing it.
Sweet wrap around.
Reloading. We've got a recharging my shields. Enemy here.
Alright.
Thermite out. Rings next door. 45. Rings close.
Enemy killed. Peacekeeper here.
Target over there.
Taking fire. Recharging shields. Throwing jump drive.
What the hell is he?
Enemy that way.
It's right there, right? Like I'm not losing my shit. That F. Is this in zone? If this is in zone. Dude. In zone.
Enemy there.
Heard that.
Round 5.
It's a solo that was shooting you, right?
Countdown.
Let's check
Like
out
down
this
here or
area.
something? What the?
Firing.
1 minute. Ring's nearby.
Reloading. Anyone up for some shopping?
Seconds. Ring ain't far. Give me a sec. Recharging shield. Ring ain't far. Half of one.
I need sniper ammo.
Not too far from ring.
was that?
Got 10.
Warning. Ring closing.
Time's up and we're not in the ring. Move now.
Oh, painless. Knocking at the door. Taking damage. Give me a sec. Reloading.
What was that dude's plan?
Squad taken out. I like what I see. Only 2 other squads left.
Don't drive him. Taking fire.
Only 1 squad left. Reload. Arc star out. Reloading.
Attention.
GG's.
Winner decided. You are the Apex Champions.
Finger hurts like a mofo. On that note, going to bed. Can only go downhill from there. That wasn't a bad game. It's not too bad. Alrighty, y'all. I'll see y'all Monday unless something crazy comes up. It is Memorial Day, so I may take it off, but we shall see. And if I do, I'll just stream on Tuesday instead. So y'all have a great night. Thanks for tuning in, and I will see you come